reference sheet. So they are not on your reference sheet. You need to remember them. Not all of them, but like the rotations ones. Also for counterclockwise, I want you to draw a little dot, boop, and then we're going to go to the left because counterclockwise is to the left. That's the main one that you go. Occasionally you'll have to go clockwise, which if you make your little dot at 12 o'clock, that's going to the right. So it spins that way. But your rules repeat themselves. So the newest one is down at the bottom. A dilation is a type of transformation that does not preserve distance, but it does preserve angles. So your angles keep your shape the same shape, just a different size. You have this thing called a scale factor, which you should have learned about in middle school. Scale factor is what you're multiplying by to change the size of the shape. So if your scale factor is technically called K, like you'll see it as K. Like, why is it K? I have no idea, but scale factor is K. If K is greater than 1, it's going to get bigger. So it's going to enlarge, it's going to increase. If K is, I normally during class will just say less than 1. But I can't, like, that's not the proper way to say it because your scale factor will never be negative. So if it's between 0 and 1, like 0.5, 0.6, 0.7, then it decreases. But whenever I'm like talking, I'll say like greater than 1 or less than 1. Greater than 1 gets bigger. Bless you. Less than 1 gets smaller. So there's only 2 graphs today. And pause real quick. You need to send somebody from your row to get calculators because we're going to use calculators today. For the first time in 27 million years. You're not going to want to use your phone because you need the fraction button. So come get calculators for your row.
Where are the calculators at?
They're probably some already out. Like he's already out. Well, there's one right next to you. Grab that one. Look around. Open your eyeballs, people. Open your eyeballs. Grab a calculator that's next to you. Here, give them to her. She needs some.
I have to put it back. 13, 27, 22.
Thank you. Okay. So we're going to start by graphing our quadrilateral, which is a 4-sided shape. So LKNM. I think I said that out of order. Whatever. We're going to plot these points. It's going to make a cute little kite. So L's at 4, 7. We only have 2 graphs today because then we're going to use just the rules to do all of this instead of graphing every single problem. 6, 5, 4, 1. Oh, I need a label. Do I have to sneeze? Oh, thank you. That was my sneeze.
She had to sneeze.
Cute. It's like a diamond. It's like a diamond, yeah. It's like a kite. Okay, so if K, the scale factor, is 1/2, is it going to get bigger or smaller? Smaller, because K is technically less than 1. Okay, it's smaller, so it's going to get smaller because it's less than 1. Now, in middle school, what you should did is you're going to take your scale factor and you're going to multiply by every single value to make your new coordinate points. You should have done it from middle school. So if we multiply by 1/2. So every single value, we're going to take the calculator, and 1/2 is very easy for you to think about in your brain without using a calculator. Some of you are going to use a calculator anyways, but we are taking each value. We're multiplying by 1/2. So the rule, because we always have a rule technically, the rule for this is 1/2 x, comma 1/2 y. Because you always have like an algebraic rule to represent what's going on. So remember your fraction button is the ABC button. So I'm doing 1.
Multiply by 2.
You're not multiplying by 2. Multiplying by 1/2. Okay, so we're doing 1/2. We're multiplying by 4. Boop. You get 2. That makes sense because 1/2 of 4 is 2. So L prime, the first number is 2. We're going to do the same thing to 7. So we're doing 1/2 multiplying by 7. which gives you this crazy nonsense. That's 3.5. So if you don't know what that is, because sometimes like it's not going to be 1/2. If you press ABC again, it's going to make it a decimal. 3.5 is 3.5. So it will change it to a decimal if you need. So M, same thing. We're going to take every single value. We're multiplying by 1/2. What's 1/2 times 6 get me? 3, because it's half times 6. So take a second, find the rest of your values. Does anybody know where N ends up?
0.5.
0.5. Good. And then K?
2 and 2.1.
What? No. What's the X? 1, comma, and then 2.5. So when we plot this, it's not going to be cute. That's why we're not going to graph stuff besides number 1 and number 2, because you're going to get decimals and it's not cute to graph. So we're going to go over 2 and up 3.5, which is between 3 and 4, 3.5. So we're going to go over 2. We're going to go up 3, 1, 2, 3.5. Boop. So it should be the same shape, but smaller. So over, wait a minute, something's wrong. Does anybody see my mistake? 6. I accidentally wrote 6. You should have said that. 6 is not 6. That should be 3. My bad. Sorry. 3. So this number should be, I accidentally wrote 6. So if you're just mindlessly copying me, that number needs to change to a 3.
So for L, we're going over 2.
So we're going over 3. Oh, for L, we're going over 2. And then we're going up 3.5. And we're going over 3. And we're going up 2.5. So it should make the same shape. It's just real bitty. It's small. So this is what it means by it keeps the angles the same. The angles of a shape is what makes the shape that shape. So the angles are exactly the same on the inside corners. So it's exactly the same, but it does not preserve distance. The distance is changing because distance means length. So it's keeping the shape, making the shape smaller. So I'm going to just lightly shape this in. Okay. So this one got smaller because K was less than 1. The next one we're going to do, we're going to start by plotting the original points. It says if square ABCD has those vertices and it's dilated by a scale factor of 5/2, determine the coordinates of A prime, B prime, C prime, D prime. So take a second, plot your points. It's going to make a square. Now 5/2. Let's go back to elementary school. That's bigger because 2 is the denominator and 2 is smaller than the numerator, meaning 2 can go into 5, meaning it's more than 1. Okay, so this is going to get bigger because it represents more than 1. So K is larger than 1. So it's going to get larger. So we're going to do the same process though. We're taking every coordinate and this time we're multiplying by 5/2. So the rule is 5/2 times X and 5/5 times y. You're multiplying both values by 5/2. So if I do -1 times 5/2, I get -2 and 1/2, which is really -2.5. What's 3 times 5/2? No. 3 times 5/2. Positive 7.5. Because 3 is positive and your K will always be positive. So coordinate, if the Y is positive, then it's gonna like and positive. B was 3, 3. I've already multiplied that. So like what? 7.5, 7.5. Because it's a square, your numbers are going to repeat themselves once you do it once. -2.5, -2.5. And then this one's like combination. So it'll be 7.5 and then -2.5. So it's going to be a little weird to plot, but it's okay. We're going over -2.5, which is between -2 and -3. And we're going to go up 7.5, which is between 7 and 8. So 1, 2.5, up 7.5. 1, 2, 3, 4, 5, 6, 7.5. So it's smack dab in the middle of that box. So it's correct, but it's awkward. So B prime's 7.5, 7.5. It's a lot bigger because technically 5/2 is 2.5. So it's 2.5 times the size. I'm just gonna like use a pencil one like this. I didn't give you color pencils today because those are only graphs we're doing. The rest we're gonna do without a graph. Yes. Yes, bring your phone. So instead of doing it with a graph, which you could, whip out a piece of graph paper and graph all of these, but it would take a long time. Either way, you got to use the rules to find the coordinate points anyways. Unless you're going like left or right or a reflection one, then you can technically count. But you can just use the rules and then get your answers. Some of you are really smart and you can do the rules, the 2 separate rules at once. So if your brain is big enough to handle that, okay, to like flip it and add a number to it or something, if your brain is big enough, because there's a couple of you that can do it, then by all means do that. Just make sure you share your answers with me to make sure it's correct. And then for everybody else, what I do is I write it out and then I change it again. So like whatever you want to do. So let's go to the back. We're going to do a couple and then you guys are just working on this. So it's everything that we've learned kind of combined together without graphs. So numero uno, that's if triangle something, because it's been hole punched out, has coordinates, blah, 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 blah. It's dilated by a scale factor of 3. So because that says it first, you have to do that first. You cannot go out of order. Then, and it's translated to left 4 units. So that's what you do second. Okay. So I have to dilate it first. So mathematically, what am I doing with those numbers? You're timesing it by 3. So the scale factor of 3, I'm taking the coordinate and I'm multiplying by 3 to the x and I'm multiplying by 3 to the y. So take a second, you're going to find x prime, y prime, z prime. By multiplying by 3, your numbers are going to get bigger because it's multiplying by 3. It's 3 times the size. So it's getting larger. Scale factor of 3. Dilation is moving the size. Yeah. Just one of the values because we're only going left and not going down. So if I do -1 times -3 and I multiply both of those by 3, what do we get? What? -3, -9. If I multiply these ones by 3, what do I get? -6, 3. Good. And then the last one? 6, -3. That was easy. Okay. Okay. Now we got to translate it. So translations are left, right, up, down. This says I'm just going left 4. So if I think about translation notation, that's from like the very, very beginning. Left is your X. Should I add or should I subtract? Subtract because I'm going to the left. So I'm going to get smaller. Does Y change at all? No. So the rule for this that I'm going to write underneath it, just kind of small. And I know there's not like a lot of space, so don't write massive. We're going left 4. So the rule is X minus 4 because you're going left. Y does not change. So it's just, if you want to put Y plus 0, you can do that. I'm just going to put Y because Y is not changing. So if it was -3, -9 in a calculator, because I know your brains suck at negatives, it was -3 and I'm -4. Where is it now? -7. You're confused? So you're not using the old points. You're using the ones you just made. So you're taking every X value and you're doing the next thing, which is -4 because it's left. Only to X. So -3 minus 4 makes -7. My Y does not change because I'm not going up or down anything. So -9 stays what it was. For Y double prime, I have -6. I am minusing 4. -10. And then 3. And then Z.
4.
Oh, not 4.
I'm 2. I'm at 2.
2. Because you're minusing 4. 6 minus 4 is 2. And then -3. And that's it. That's my answer. These will 100% be on your EOC. I would bet money, big money, that you will see this 100% multiple times on your EOC. Okay. So 2, it's kind of like annoying. Is it hard? No, it's annoying. Yes, whatever. So it just means it's going around the origin. So it's usually always gonna say like centered around the origin. The only time it's not is if it's a rotation. Yeah, so the rules are the same. Huh? No. So 2 says determine the new location of ABC if the triangle is dilated with a scale factor of 2 centered around the origin. We're not spinning or anything. Dilations are always centered around the origin. So for this, I am multiplying by 2. So the rule is 2x, 2y. So that's all you have to do for this one. So take a second, find your coordinates. It's getting larger. Multiplying by 2. Easy peasy. These numbers end up big. That's why there's no graphs, because you don't want to graph this. So where's A end up? 2, 6. You're a genius. Where's B?
14, 4.
14, 4. 18, -4. You don't want to graph that because those numbers are massive. Ugh. You would graph it, but like it would be really rough. Okay, see if you can do the next one. Start with number 3. Determine the location of trapezoid WXYZ after a dilation with a scale factor of 3/2. Then reflect it. So first, you're doing that's why we have calculators. We're going to use a dilation of 3/2. So you're multiplying by 3/2 to every coordinate. Use your calculator. Use your fraction button. I do. I don't even know how to see this. It's usually like that, but Yeah, please.
Oh, so you do the fraction first.
Yeah, because it says that first, we do first. We gotta do our fraction first. Because 3/2 is gonna convert to 1 1/2 in your calculator,
Oh.
which is fine.
Then you multiply
And
by.
then multiply it by your numbers. Because it's like an improper, right? An improper number, and then it changes to a mixed number. Yes. You make whatever the rule is, which is X is positive and Y changes to negative, but if it's already negative, it's positive.
This house.
Yeah.
On God,
Right, it's positive. So it'd be X plus. People who are smiling in the head with me, because they can handle it like that.
Wait, what one do you click and make it?
To make it a what?
Like, when it's like abstraction.
Then you click ABC again and it'll convert it back to a decimal to a fraction. ABC. Nope, we're not. Because it's on your UC. And once we get going, it's not gonna take long. People are still finishing. Yeah, I mean, that's because you like to dilly-dally. Okay, if it was 4, 6, and I multiply by 3/2 using the fraction, what do I get for W prime? 6.
See?
It's not 6, 9. Is it 6? It's not 6, 9. It is. Sorry. I'm crazy. I'm looking at the wrong paper. 6, 9. Okay. What's X prime? 3, 9. That's the one I was looking at. And then Y prime? 1.5, comma 6. And then Z?
7.5.
Yeah, there's another one.
7.56. That one has a lot because it's a trapezoid. It says Z. You missed a point. It says Z.
Oh, I'm so slow. I'm
No, you're multiplying by 3/2. You're always multiplying. Okay, now you're reflecting across the x-axis. The rule is that your x stays the same, reflect across the x-axis, x stays the same, y becomes negative. So if it was 6, 9, what is it now? 6, negative 9. If it was 3, 9, what is it now? 3, negative 9. Y will be 1.5, negative 6, and Z will be 7.5, negative 6. See if you could do number 4. We'll do 2 more together. Try number 4. It says a dilation of a scale factor of 1/2 first. What you got to do first. Dilations always are multiplying by the scale factor. Okay, A was -1, 2. What's A prime? Perfect. B prime.
-2 coming.
Good. And then C prime.
-3 coming 0.
Perfect. Okay, good. So that's the first thing. We dilated by 1/2. So I basically multiply everything by 1/2. 1/2 is easy to think about in your brain. You're really just dividing by 2. But all the other ones, you use the fraction button, okay? Don't overthink it. Then I'm rotating 180 degrees. It doesn't say direction, clockwise or counterclockwise, because 180 does not matter what direction you go. So 180, what's my rule?
Negative X. They both negative Y.
Negative X, negative Y. So all you're doing is changing the signs. So if it was negative 0.5 and positive 1, it's just the opposite. It's going to be positive
0.5.
negative 1. B was negative negative. Now it's positive positive. And then the last one was negative positive. Now it's going to be positive negative. How do we feel? Feel okay? Okay, last one you're going to try number 5. And then we'll talk about the answer. And then we will work on the rest of this. Start with your scale factor. 7. Use your fraction button. 2. 7. Now that is technically getting bigger.
I didn't do that.
But it's not. Yep. And you'll see if you press a number, like put a number in first. Or negative. Yep. This is getting really big. 7/2 is technically. Yeah. Yeah, 3.5. So it's getting 3.5 times the size. It's all the x's, every x. And then every y will get -3. That's translations. It's in vector notation. Vector. Huh? Oh, it's a direction. So this is positive. So that means you're going right 3. And you're not going up or down anything. So if you're going right 3, that means you're adding 3 just to the x because it's positive. Okay, so if it was 7/2, Q was 8.6. It's massive now. What is it now? Like 28 something? 28. 21. Good. And then R prime. Good. And then S prime. -7, -14. Now we're going to use translation notation, but it's in vector form, like Despicable Me. Vector. It's a direction and a speed. Okay, which are good. So the first number represents X. The second number represents Y. So it's positive. So we're going right 3. We're not going up or down anything. So we're going to add 3 to X. So we're doing X plus 3. Y stays the same. So Q was 28, 21. What is it now? $28, 31, 21. Is it 32? No, it's 31. 28, 29, 30, 31. You added 4. It's adding 3. -14 plus 3 makes -11, 14. And then S double prime, I'm adding 3 to X, which is -4, -14. Those are your coordinates. Yep, so you'll multiply by 3.5 for the next one. So sometimes they're decimals, sometimes they're fractions. You're multiplying by 3.5 for the next one. Okay, keep going. These are 100% on your EOC. This is very important. That's why chapter 4 has felt like forever, because it is forever. Spend a lot of time on it because it's important. Keep going. You got this.